but here we go this week. I recorded a first video, and this is the second video. They go hand in hand, but here's me actually working it out and guiding you through it. So, this is example 1. It's number 36 on page 202. You'll notice these are the ones that I want you guys to do. Try 35 to 57 odd. So, here we go. One of the hints is, and this is all from that brown box on the other page, it says work on the more complicated side to get the easier side. Well, the right-hand side, this is called the right hand, or RH. This is called the left hand. The left-hand side is more complicated, so I'm going to start there. Now, I want my answer to say sine alpha. So this tells me I should convert all this stuff into sines and cosines because I need a sign for an answer. So let's begin. I am going to do a left hand only answer. I'm not going to touch the right side. So the right side's going to stay the same. When I get done, that thing's going to just say sine alpha. So here we go. On the other side, I'm going to take the top part here, and I am going to rewrite it as sine alpha divided by cosine alpha. That's one of my fundamental identities. Divided by secant alpha. Well, secant alpha is the same as 1 over cosine alpha. I just created a double fraction. That's okay. I am going to multiply the top part and the bottom part by cosine alpha, not x. Ooh, I made that an alpha. Here we go. And then if I do that, these will cross cancel. What's left in the top? Sine alpha, that's what's left. These will cancel. What's left in the bottom? 1. Sine alpha divided by 1 is the same thing as sine alpha. These two guys are now equivalent to each other. So once I have the left hand equal to the right hand, I draw a little box because that shows whoever's reading your work, you have completed that problem. That one's done. So let's look at the next one I picked out for an example. The next one I picked out for an example is number 38. So number 38 looks like this in the beginning. It starts off with tangent squared alpha plus 1, and that should look really familiar because I'm about to tan in 1 sec. So that's on the bottom of number 38. And what's the answer? The answer says we want this to look like secant alpha. I am going to do a left hand only proof of this identity. When you are working, you will tell me at the beginning whether your answer was done by doing left hand work, right hand work, or sometimes both. So here we go. This guy right here, I look at this and I say tangent squared alpha plus 1 is the same thing as secant squared alpha. I have not changed the bottom. The bottom says secant alpha. Well, this is the same idea as x squared over x. Who's more powerful? The top. By how much? By 1. So I can reduce this. Just like I reduce quotients, I reduce trig functions. So I could say, oh, the top part keeps this. The bottom part would cancel out. I could put a 1 on the bottom if I want, but I don't need to. But as you can see, these two guys are now the same guy. When the left-hand side of your problem is the same thing as the right-hand side, you are done. And you just draw a box and color it in. That means whoever's reading your work, they know that you are not going to show any more steps. That's all you needed to show. Now, here's the thing. In the first one, I chose to rewrite everything as sines and cosines. In the next one, I used an identity to substitute. They're all different. Things are different, and every problem takes a little bit of practice. But as you can see, I went one step, two step, I was done. By the time I got to there, they equaled each other. If you're doing anything that takes you 8 steps or more, you picked the wrong way to go. None of the problems I picked out you should have to do that many steps to get done. So here we go. I'm going to look at another one. You can rewind this video, you can pause it, you can do whatever you want to help you out, but my third example here that matches up with my first video is number 46. So number 46, it starts off like this. It says secant fourth x minus secant squared x equals. And on the other side, they gave me tangent fourth x plus tangent squared x. Now this is a identity where I am going to work on both sides. I'm going to keep everything on the left of my dashed line. I'm going to keep everything on the right of my dashed line. But this is one where I can work with both sides. And the reason I chose to do that is I see GCFs. Remember, the brown box that I showed you in the other video, it's really good hints. If you see this thing is lousy with GCF goodness. And if I see GCFs, they're trying to tell me something. So I'm going to take out the secant squared x. And I'm just going to say, what would I need to multiply it back by? Well, secant squared x times secant squared x would give me a secant fourth. Minus 1 would have to hold the place. It would totally have to hold the place. And you might look at that and say, well, I don't have a formula for that. I have a tan and 1 sec thing going on. But think about it. This is when, I'm going to write it down at the bottom here so it's away from the action. Tangent squared x plus 1 is equivalent to secant squared x. So this is in the brown box. They say sometimes you will want to use an alternative version of one of your formulas. If this guy was on the other side, then I would have, hey, that's the same thing as, you guessed it, that's tangent squared x. So I have tangent squared x times secant squared x. Now, pause for a second. I know I could do stuff with that. I totally could. But don't forget, what is the strategy I'm working with? I'm working with GCF. So I'm going to go back to the top here and go on the left, or sorry, the right-hand side, and take out a tangent squared x. And then I'm going to say tangent squared x times tangent squared x would give me the tangent fourth, plus 1, that would hold the place. And then I go, wait a minute, I don't even have to manipulate this one. This guy, tan and 1 sec here, that is my secant squared x. That's what he is. Times what's over here? Tangent squared x. Well, heck, those two things are equal to each other. They are. You know, multiplication, it doesn't matter which order you write it in, as long as it matches. 6 times 2 is the same as 2 times 6. That's okay. You can totally use that. So this side right here and this side right here, they match. Now, I did this in the first 2 problems. I just want you to know, you do not have to do this. Sometimes it's just to be helpful, but when I write left hand equals right hand, it's not necessary. This is pretty obvious that the left side equals the right side. But some people like to do this. I don't poo-poo it. I don't care. But do this for me because I want to know when you're done writing, you're done writing. I don't want to try and figure out if there's anything else to see there. But take a look at it. That's a 4-stepper. I did 2 steps on this side. I did 2 steps on this side. That's 4 steps, and I had both sides equal to each other. Any identity, the object of the game is to make one side equal the other side. So I'm going to scroll down and we're going to do the next one. Now, number 48, this is why I made two videos. Number 48, I wanted to show you the fastest, easiest way to do number 48. And I also wanted to show you what it looks like when you're wasting your time. What does it look like when things aren't working out for you so well? So here's the thing. When you see problem 48, it starts out like this. Secant alpha minus tangent squared, or it doesn't say tangent squared. Hang on, I'll get rid of that. It says tangent alpha squared, like that. That's a different dude. What does that equal? It equals 1 minus sine alpha over 1 plus sine alpha. Now, this is the last hint in the brown box. The last hint in the brown box says something about multiplying top and bottom here by its conjugate. So that's what I'm going to do. I am going to take both top and bottom here and multiply it by the conjugate. Now, this particular identity, I have to work on both sides. But when I see this set up on the right-hand side here, conjugates are usually a really good trick to use. Why? Look at what happens on the bottom. Just on the bottom. I'm only showing you the bottom part. If I FOIL that, I will get 1 times 1, that's 1. 1 times minus sine alpha, that's minus sine alpha. That's what I get. Then 1 times plus sine alpha, you can see those are going to cancel. And then last but not least, I get negative sine squared alpha. These guys are gone. And this trick right here, where I have 1 minus sine squared alpha, learn to recognize this guy. This is a variation of this dude. If I move this to the other side, 1 minus sine squared alpha equals cosine squared alpha. So when I did this, I worked in the denominator only so far. But in my denominator, I have cosine squared alpha. That's what I have. Now look at the top. In the top, what do I have? I have 1 minus sine alpha times itself. That's what I have. Now, you got to learn that if you're going to work on both sides, don't try to do too much at once. I'm going to stop right there, but that's because I haven't done anything on the left-hand side yet. Let's start playing with the left-hand side. And here's the thing, don't FOIL it. If you do, that's why I made the other video. You can get there, but you're going to do like 13 steps. What does the right-hand side look like? It looks like sines and cosines. So let's rewrite this. I'm going to take this whole top part here, and I'm going to say, hey, buddy, you're the same thing as 1 over cosine alpha minus, what's tangent? It's sine alpha over cosine alpha. And the whole thing is being squared. Do you notice that they already have common denominators? Put them together. I could say, oh, you already have a common denominator. In the numerator, I could rewrite this like this. Let that sink into your brain for a second. But wait, there's more. This thing is being squared. Well, heck, if it's being squared, that means the top part gets squared. The top part gets squared. And the bottom part gets squared. And then I go, Shazam! Oh. the left-hand side equals the right-hand side. So in the book, if you read through this section, because they have 5 examples in there, and they're good examples except for the 5th one. The 5th one is really hard to read. I'm a good, math geek, so I can read it okay, but man, I've had years and years of training. Example 5 in the book is hard to read through, but there is a really good thing. Sometimes to solve an identity, it helps to make the left side and the right side equal to something they both represent. A common third thing they could both represent. This doesn't look like the original. This doesn't look like the original. But we don't care as long as we got one side to equal the other side. That's okay. That's what a both looks like. 48. Compare it to what I tried to show you for the dead end way to do that problem. And then you'll see why I picked that out. All right. Now, my next example is 58, and then I have one more, and then we're done with the examples. But example 58 is on page 203, so I'm heading down the other way. I have you guys stop at number 57, but here's number 58 for example, because this guy starts off as sine fourth, is it an alpha? It looks like an alpha. Alpha minus cosine fourth alpha. On the bottom, I have sine squared alpha minus cosine squared alpha. Equals, they want it to say equals 1. So take a second. Do you think I'm going to do a both sides? No. I'm not going to work on the right-hand side. It says 1. I want this thing to say 1 when I'm done. So this is definitely going to be a left hand only. So when you guys do an identity, you're going to always tell me at the very beginning, is it going to be left hand, right hand, or both? So here we go. Left hand only. Here's what I don't want you to do. What I'm about to do is so wrong. Don't do this. Somebody's going to do this and it's going to hurt. Hey, I'm going to do that. That's just sine squared alpha. Hey, I'm going to do that. That's minus cosine squared alpha. No, it's not. The top part, the original top part here, was a binomial, and the original bottom part here was a binomial. They don't match exactly. You don't get to do that. You don't. Don't do that. But think of it this way. The top part is the difference of squares. Sine squared alpha plus, sine squared alpha, plus cosine squared alpha times sine squared alpha minus cosine squared alpha. Sorry, I lost my head for a second there. That's what the top part is. It is the difference of squares. So don't cancel stuff when you know you should factor it. Now look at the bottom part. The bottom part was this. And I could put it in parentheses if it makes my brain happier. Now I have a binomial that matches exactly top and bottom. What is it supposed to equal? It's supposed to equal 1. It is. Oh, it's supposed to equal 1. And it does. Because this guy right here is a fundamental identity. I have sine squared alpha plus cosine squared alpha. That equals 1. It does. What's it supposed to equal on the right-hand side? 1. I say that I am done. Be aware. Don't jump the gun. I put number 58 there not because it's super difficult, but because people make wrong choices. Canceling before you factor is a wrong choice. But once again, I say, hey, I am done, reader. I hope you understood what I wrote. Last but not least, this is the one that I wanted to make sure everybody saw. It is my example number 59. And you don't go to 59, of course. You stop at 57 today. But some people are super, super afraid of going into complex rational town or double fractionville. This is one of those problems where if you take the original, which says tangent squared t, I hate it when they use t. Oh well, they use t. Tangent squared t minus 1 over secant squared t. What's it supposed to equal? It's supposed to equal tan t, tangent t. Is it a minus or minus cotangent t? God, I hate that. I hate the variable t. Tangent t plus cotangent t. Now, once again, don't cancel stuff. These are binomials in the top and bottom, and they don't match. You don't get to play with it. But the thing is over here on the left-hand side, by the way, I'm going to do both when I do this. This is a both. You really are tempted to make tangent squared t minus 1 into some kind of secant thing, but it doesn't work that way. No matter what you do, this rule, I'm writing it down at the bottom here, this guy right here, this is a positive 1. It's not a minus 1, so there's no way to recreate this thing to help you in this situation. This is going to lead you to a dead end. It's not helpful always, but you might not figure that out. So I'm trying to give you a big hint here. But guess what? This one is super sneaky. If you want this to work out easy, here's what I'm going to do. I'm going to take the tangent squared t. I'm going to call it sine squared t over cosine squared t minus 1. Then on the bottom, I'm going to take secant squared t and make that 1 over cosine squared t. I'm now going to take the entire top and the entire bottom, and I'm going to multiply everything by cosine squared t. I'm going to do it here too, cosine squared t. When I do that on the bottom, they both cancel. I get 1. On the top, the first fraction, these guys cancel. On the second one, it just says this. Now, you might look at that and say, hey, that looks familiar. I saw that in another problem. But here's the big takeaway that I want you to see from this. My first step was to rewrite it as double fractions. My second step was to cancel out the double fraction. I'm going to just pause for a second here and say, let's make the right-hand side all sines and cosines now. Tangent t, I could rewrite that as sine t over cosine t. Minus cotangent t, I could write that as cosine t over sine t. That's just the numerator of my right-hand side. Let's do the denominator. The denominator would be sine t over cosine t plus cosine t over sine t. I rewrote everything with sines and cosines. Now this is a different double fraction than I have on the other side, but I'm going to use the same type of strategy. I'm going to say, you know what? I need to multiply the whole top and bottom by cosine t to get the cosine t's out of the bottom. But wait, that's not going to do anything to the sine t's, so I got to use that too. Now what I'm writing down, this step right here, do not leave this step out. You show me this. You be polite so I understand where you're going. But if you clean this baby up, you are going to find that you're done right after this step. Play along. If I do distribute that, the first part, I'm going to change to red so it's easier to see. Oh, come on. Well, reddish. Come on. There we go. When I do the first drop, the cosine t's will cancel. They will. The cosine t's will cancel. What'll I get left with? Sine squared t. In the second move, the sine t's are going to cancel. What do I get left with? Cosine squared t. And notice in the top part, it's a minus. That's just doing the top part. That's the top part of my answer. I'm going to change colors once again. Let's see. I haven't done green. Let's do that. If I do this right here, what's going to go away? The cosine t's. What's going to be left in the bottom? Sine squared t. Plus, what's going to go away in the second part? What's going to go away here? The sine t's are gone. I get cosine squared t. Oh, squared t. And then I look at this thing real close, and I go, hey, you are the same thing as 1. Which means I have, oh, God, wrong thing. I have, come on, go back to black. This side on the left-hand side. That's what I want to stop with. That's a good guy. Me gusta mucho. Over here, I have the same thing. I have sine squared t minus cosine squared t divided by 1, which is just that one thing. The left-hand side and the right-hand side, they equal each other. It's box drawing time. Nothing feels better than draw that box. Okay, so that's me walking through some identities to practice. That's what your work looks like. By the way, I'm just going to scroll through this again. That's the last example. And that actually was only like 7 steps grand total. That's a big one. Here, that was only 2 steps, as long as you pick the right 2 steps. This guy right here, I showed you the quicker way to do it here. But you know, here's the thing. If you end up going down the wrong road, you're going to know it. Because you'll go 5 or 6 steps in and it looks worse than it did when you started. It means crumple that piece of paper up and try again. Okay, and then this guy, this was to remind you that factoring is your friend, GCF City. And then this last dude here, or sorry, I had one more before that. That means pay attention to things you already know. And you know what? When you work through identities, the more you do, the better you get. And sometimes you might be like, am I on the right track? Am I not on the right track? You know what? That's the hardest part about being online right now is in the classroom, I can tell you right away where you're at and where you're not. So this is going to be a learning curve for both of us to figure out how to do this the most efficient way. But that video lesson I just gave you, hey, take it to heart. Look at the hints on that brown box.